Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. So we have with us for this great month of July, Mikey Bronowski, who is going to talk to us about CHECKDB. And please, take it away, Mikey.
Thank you, Kevin. Thank you for having me tonight for me, this evening for people overseas or wherever they are. Yes, I'm Mikey Bronowski, and today I want to talk about CHECKDB or how to handle, well, not how to handle, but at least give you some ideas how to deal with the long-running CHECKDB, or what to check with CHECKDB. And it's based on some of my experiences. It's not a complete guide, but some ideas maybe you can use at your work. So first of all, why I chose this topic. In many places where I work as a DBA, the CHECKDB probably was one of the main concerns, one of the main issues, and depending on who was the owner of the server, it got different approach or different treatment. So in some places the CHECKDB was running too long, so the cutoff was like a midnight for that server, and if CHECKDB was running over like till midnight, it was stopped, but it was like brutally killed, the whole thing, and the database that was being checked was actually not being checked, and that process was killed for months. So it was not actually being validated for corruption or anything like that. The other reason for CHECKDB being a problem was it was like heavy processing, and the system that it was running on was very high. The activity was very high, and running the heavy operations like CHECKDB was always a problem. So it was lower priority for the business to keep the application running rather than having the CHECKDB at the same time. And some other places that the CHECKDB was never configured, and for different reasons. Sometimes it was people were just scared because they heard the problems, like, oh, it's too heavy, oh, it's going to run forever, or we don't know how to configure that. So those were the reasons for this topic. This is the brand new topic and kind of different from what I usually talk about and show, as I prefer demos. And today I'm going to talk about the stories or some of the ways how to deal that. But first, before we go there, let's bring this concept or operations to people who might not be aware what the DBCC commands are. So basically, there are three groups of DBCC commands, database console commands, as we call them. There are commands like for maintenance and for informational purpose and for validation. And in this presentation, we will focus on validation, which DBCC CHECKDB is part one of the validation commands. What are the other commands? We have check allocation, check catalog, check constraints, check DB, check file group, check table, and check ident. This is here on the validation, but it works differently. It doesn't check for the consistency for corruption. It checks for the identity values. So we are going to skip that part because it's not usually part of the usual consistency checks. But all other 6 commands are where CHECKDB being the main command covering all of them, and sometimes being the default if it's configured. So why focus on CheckDB? The CheckDB is the key command for maintaining the integrity of the database and checks for corruptions. It performs different checks, different integrity checks, verifying logical or physical consistency of the data pages, rows, indexes, and so on. It also has options to repair some easier corruptions or low-level corruptions and fix some issues. Sometimes it can fix things, but there is a risk of losing data as well. The CheckDB, if we run the CheckDB, it contains it's made of multiple tasks. These are not like the order of execution or things like that, but when we run CheckDB, we can expect by default we check the database. We don't repair. There are options to perform some repair on the actual database. So for now, we are skipping that because usually when the maintenance is run on the regular basis, we don't do repair. Like it's not scheduled. We react when the check doesn't come up clean. So we have the table check, which checks the logical and physical consistency of the objects. We have the allocation structures to be checked, and we have system tables as well. The SSB check stands for the SQL Server Service Broker check, which is not like a separate check. You don't issue that separately, like for table or allocation or catalog, which is the next one. But it's there, and it might be one of the reasons why it's slow. But I will go back to that later. The check catalog checks the consistency of database catalogs, as the name says, and the iView checks for logical consistency of any indexed views. So this is just a description. You might see that when you run the SP who is active or some trace, you see those commands being executed, for example. Going back to CheckDB itself, we have few arguments to run. I won't be focusing right now on the repair part. As I mentioned, we just want to talk about the checking. But as you can see, there are 3 options to repair things. But one of the options is like no index. So it's that argument skips the checking non-clustered index, which can speed up the checks, but may potentially miss some issues. And there are situations where the corruption exists in non-clustered index, for example. So probably one of the easiest I had to deal with was to simply drop that non-clustered index and recreate, and that fixed the corruption. But we need to check for that corruption in these places. There are other options for CheckDB, like we have physical only, which will check the physical consistency without the heavy logical checks. And sometimes this is recommended way for certain scenarios to just run this quickly, so at least have some level of validation. We have also data purity to check the data types, or maxed to control the degree of parallelism. Estimate only is not actually it's not actual check. It's estimation of the space required. And I remember a case when DBCC CHECKDB couldn't finish, and we were investigating that. And but it was running very long time until it stopped. So the idea was to run the estimate only, and we found out that the space needed for that operation to finish was actually more than we had on the drive. So we knew that this is the issue. We had to expand that drive to be able to continue with the CHECKDB. Tab lock operation option. That's something to log the to allow the operation to log the underlying table, because when the CHECKDB runs, it works based on the internal database snapshot, and this will allow to avoid running the snapshot by. I will mention that later in this presentation. We have some other options as well, like non-info messages or extended logical checks or all error messages. Some of them are not. Some of them are like hiding the noise. Some of them are like showing you everything in case you need to troubleshoot. So these are the options. And now the snapshot. So let's mention like when snapshot is not being executed. So the internal database snapshot is not executed when there is a database in single user mode, or on master database if the instance is in the single user mode, or if the database is in read only mode, or by design it doesn't run on tempdb. And with the tab log option, we skip that internal database snapshot part, which might be helpful in a specific situation. And I will not show you, but tell you about that in a second. And the last bit, well, it shows the X, but it's actually how the snapshot that is being created and if the files look on the server. So if you are not familiar, that when you see the extra speed, extra database, so it creates the extra object in this in the databases, in the database list. It has the ID which equals like database ID +1, and the file on the drive would be whatever you have of whatever the database file you have, with like a MDF, NDF extension, or whatever extension do you use. If it's non-standard, then it has the _MSQL _DBCC and the ID of the database snapshot. So just to give you an idea, like what is happening when you kick off CHECKDB. And the last bit of the introduction is implementing DBCC. I don't have specific codes because you can do this for every environment like different ways, but probably one of the most popular way I saw or I experienced was using maintenance solutions by Ola Hallengren, where you can not only create the CHECKDB database consistency check, but also reindex and backups. But it has the option to just create the CHECKDB, and then there are different parameters, different options. It is actually, I might just show the website. It's open source, it's free, and you should be able to see that page. Server maintenance, SQL Server maintenance solution, and then we have the integrity checks here. I'm just going to do that. So you can download the whole maintenance solution. I think that link goes to GitHub, or maybe it's hosted on Ola's website. And then we have all different parameters like databases, and you can see some nice labels like system databases. That takes care of the system databases or user databases. All databases, you can have all different combinations like wildcard or exclude certain databases, which is for the way I was configuring the other method later on to deal with the long-running CheckDB. That was very handy. And we can also have check commands and to apply different commands. So we can either run the full CheckDB or split them into different sub operations, or even run them like a list of these operations in a single job step, SQL agent job step. And we also have like physical only. I mentioned that option before, data purity, no index, and so on, including tab lock. All the options here, all the options from CheckDB that were mentioned before are in maintenance solution by Ola. The other way to configure the CheckDB, the maintenance solutions, would be using DBA tools. If you have more than 2 instances, probably, maybe even more than one, it's always nice to use some kind of automation. So where's my browser? So DBA tools. Well, that is GitHub. That's the project on GitHub, but the main website is dbatools.io. And that is a PowerShell module to manage SQL Server, and it's like a management studio capabilities in command line. And if we go to commands, we can scroll to DBCC, and you can see there are, these are actually are different things, but maintenance solution is here. So we can install the maintenance solution and then do things with Ola as well. So that's one way to manage or deploy the database consistency checks. It's also very convenient, like with DBA tools, you can control if you have the AG setup and you want to inject that one step, which is very popular, to check if the current instance is a primary or secondary, wherever you run the command. With DBA tools, you can insert that step to every job and every instance you want, and with one or maybe 2 lines of code, you can inject that code, that step, and job done. You don't have to do this manually. There are some configurations on the Ola side as well. Like we have things like availability group databases, so it will be all the databases within the availability group. And the last bit, I need to mention that, but because it's kind of built-in solution, it's SQL Server maintenance plans. You pick them from Management Studio. There are maintenance plans. I use them only in one place. That was before, I think before DB tools times, and that place didn't have maintenance solution by Ola. So we were using integrity checks from maintenance plans. I have to mention that it is there. Some places use that, but I recommend, if it's possible, if you can use third party, because maintenance solutions by Ola or DB tools is third party. So some places are very restrictive about what you can install in your environments, but if you can just try other solutions than SQL Server maintenance plans, because it didn't, at least at the time I was doing this years ago, it didn't handle very well, like if database was not available, the whole task was failing, or you had to maintain the old DTS packages. If you had multiple versions, so you had to still have the old version in case you need to change something and deploy that to other versions. So just, it's there, but don't use it. That's my recommendation. Okay, so that was the introduction to the CheckDB. What is CheckDB? Database consistency on different levels, and how to get it into your environment. And now I have few scenarios where the CheckDB was running slow. So the first one was it was just CheckDB, then the main command, the big command with all databases, just a very default one, and it was all or nothing. Well, kind of, because it was failing on some databases, but if it hit the biggest one, or it was in a busy period, or got to the point where it couldn't run anymore because it was killed, some of the databases were not checked, and that was the case for one very large database. Well, I say very large, but it was very large for that environment. It can be like sometimes 100 megabytes, 100 gigabytes can be very large for environment. Sometimes it can be 2 terabytes, but for that it was few 100 gigabytes, and that was it. It was going over the approved time, so it was killed. It was the whole process in this scenario will run very long if you have lots of databases. Of course, we are not talking if you have multiple databases and they are not very big, and the tables are not very big, then you probably don't have any problems. But in most cases, there is something with like a big database, or some other diseases, let's say, or configurations that might hurt you, but you don't know yet. And with everything in one step, like CheckDB, all databases, you don't have the full visibility of what is being checked at the moment, as CheckDB contains multiple operations and it runs on different tables. So if you have, let's say, 400 tables, then you just see like the whole thing being checked. And with all our solution, there's a command log table, which logs every operation that was executed with the timestamps, with the commands, so you can troubleshoot if something is wrong, measure that. You can compare that with the error log as well, where the operations are logged. But with CheckDB, there is a limitation. It's just a single operation, so you see less. Excuse me. So the other, I will present the potential configurations, the configurations that I've met, but then we'll go into some of the solutions, let's say. The other scenario is to split CheckDB, to split the databases. And that's very common as well to way to handle that. So we split the system databases. We run them sometimes on different day, maybe. The system databases, if your setup is in a G, on every G replica, you have their own system databases. So MSDB or master database on replica A is different than on replica B, whereas the databases within the AG, although they have different storage, they will be like the same, and probably depends which, like if you're running the primary, you want to check the primary if that's the one you're using to do the operations and do the backup, so you work off the same place. And I didn't see running the CheckDB operations on every replica in AG yet. It was always either the primary or a dedicated one replica. So for the split, system databases either in the same agent job or different agent job, but it was just CheckDB, all system databases flagged. That's a parameter from Ola Hallengren's maintenance solution. The next job was user databases. So all user databases were in this step. And if they were large, we have similar issue as this issue number 1. We don't have the visibility of the tables or what is happening. It just runs database by database, and it might be similarly long. With the Ola solutions parameters, you can exclude certain databases, so you can split them into dedicated jobs or steps. So let's say you have job 1 system databases, job 2 user databases, which are, so let's say, small or not big or large, and then you have a 3rd, 4th jobs for a large databases. If there is a environment with 10 databases and 2 are really big or 3 are really big, you can split them with the separate CheckDB job for that database. So they can either run in parallel or on different days, and that will help you to spread the workload. Of course, it depends on your environment, but that's just an idea of potential scenario. If you go further, you can see that the CheckDB is split, but in different way. So we don't run the CheckDB, but we run the sub operations or the other commands like check allocation, check catalog, or check table. And in this way, we will see separate rows in this command log table. When you see check alloc for the whole database took this long, check catalog or check table, and then you see the list of the tables, which gives you more granularity and information about how your process is performing, or where is the pain point in that process. So this would be, instead of splitting CheckDB into databases, we now split the CheckDB into sub operations, let's say. With that, we don't run certain operations. So we just run like check alloc, check catalog, check table, and I showed that we have we had these operations: check alloc, check catalog, check table. Check file group is a bit different. If you have lots of file groups, and then you can also split that as well. But CheckDB is the main one, the big one, and the other ones are here: check alloc, check catalog, and check table. Okay, that was the different kind of split. service broker, that was new to me a while ago, and the database itself was well, what happened? We had a split for separate jobs for databases, separate job for. It was just CheckDB, yeah. But the database itself was not that big, so the large databases were excluded, and that one was part of the other databases, and we couldn't understand why this database was taking very long to process. It was very odd because there was a database in similar size, and it was run very quickly, and we investigated that. There was no other issues with, like, they were on the same storage, nothing else. But then the light bulb came up, and we noticed that the database had the service broker enabled. So this information here, the first three lines, three system views, or I think those are system views: sys row set column, sys row set, and sys units are from the service broker check. And for that database, it had thousands of entries, and that took forever to process. And what's even better, that service broker was not in use. There was something with the database that it had to be on the server, but the service broker, like, we didn't disable that. So the full CheckDB checks that service broker part, and the command was the SSB, and the way I found it was, like, when the CheckDB was running, I ran the SP who is active, then there was this DBCC SSB check, and I was not familiar with that bit, so I checked that. I Googled, it was before ChatGPT, so I Googled that, and it came like, okay, this is the service broker part. And one way to stop that check was to use DBCC check table, because it won't process it won't kick off the service broker. So yeah, that was one of the things that took forever, and it was a big mystery for a while. And once all these things were sorted, we had system databases separated, big databases separated, service broker separated, database with service broker separated. There was still an issue because the database had something like 500 tables, where I think only 20 were bigger than 1 gigabyte, something like that. And with the separation of DBCC check table, we were running table by table, but it was painfully slow. And while for the top 5, the biggest tables, that was kind of like, we thought, like, okay, this is normal. For the next 15 tables, it was like, yeah, nothing extraordinary. But for the smallest tables, sometimes with, just one row, it was taking too long for the table. And what happened was, the internal snapshot that was created for every single table, so that overhead for 450, 400, I said 20, 480 tables, was added per table. So the smallest tables, which normally run very quickly, at that time were running very slow because the database itself was huge and very active. So that's the main reason. It was very, very active, and the snapshot took a good amount of time to be created, then allowed to quick check table, and then move to another table, which again, because the database was really, really active, the snapshot took again some time, and that overhead caused hours of delay. Once we identified that, we were able to separate the measure how long the check table with tab lock will run on a bigger table compared to one without tab lock. So the risk there was the system is very active. If we lock the table because we use the tab lock for CheckDB, how this is going to affect the system. So the decision was, okay, let's leave the internal snapshot for bigger tables because the overhead as a percentage, as a proportion, is not that big compared to the processing time. But for the smaller tables, let's go with the tab lock. And that improved the things massively because we no longer were, SQL Server was no longer creating the snapshot. It was running through 480 tables, or maybe less, because some of the bigger table took a little bit longer. But there was no extensive blocking in the system, so we were okay with that. So it massively reduced the time to process the whole database. And I think we had 2 databases like that. So you can imagine every 100 of small tables added few seconds, and if you add 400 at the times multiple seconds, then it adds up quickly to a good amount for overall processing. There was a point. I think that those are the scenarios. So now I already mentioned a few solutions to all the scenarios, but just to sum up the solutions for the system databases, in most cases it was just the DBCC CHECKDB, like a job, run, system databases, take care of all of them. We don't have to split anything, just run them all with all the options. Unless maybe your MSDB database is crazy big, where there is no cleanup on, but that's a different issue. But you can do the cleanup, but also it's worth to check that if the backup history or job history is being cleaned up properly. So one job, system databases, done. The other database with service broker, split the operations into sub operations. Instead of running CheckDB, run checkalloc, check catalog, check table. The service broker is not being checked. That was in our case. It might be different if you care about the service broker. We didn't at that point. So and we cared more about the time for the database. For large databases, split the sub operations, check alloc, check catalog. That those operations were usually very quick. Check table on largest tables with the internal snapshot, just to avoid, if for very active database, for very active application, just to avoid clash with the application side or high activity on the server. For smaller tables, use with tab lock option. Good idea is to have kind of a dynamic solution. So every time you run the script, you don't have a set of tables. You can do this with Ola, where you just provide like table parameters, and it will be like, oh, these tables are big, so just process them without tab lock, and all the tables except those process with tab lock. But we know that this is not very flexible solution, and more often we see that we set up something in the environment, and year from now, 2, 3, 4 years from now, the environment changes. Someone develops a new feature, developers add new feature, there is a new table that grows massively, and then it's no longer considered small. It's one of the biggest or somewhere above the threshold. So it's good to have like a dynamic way to tell this table is bigger than, let's say, 1 gigabyte. In my case, it was 1 gigabyte, or maybe 10 gigabytes. Either way, you just measure your environment. If it's above 10 gigabytes, move it to the large database tables. If it's smaller, process them with the smaller tables. I didn't include the part here, but I think it was Paul Randall on his blog put kind of an algorithm to split tables. Was it tables into buckets? I don't remember now if that was tables or databases, to put them into different buckets and somehow like balance the size to be processed. So in this way, you don't have like all the big databases in one go and then all the smallest. You can just dynamically balance them so they are equally grouped. So that's one idea as well. It will work for other databases, like if you exclude the system databases, service broker things, very large databases, and then you might have other databases that are not very large but are not very small. And I worked with the systems where there was like 100 databases, and still processing them in one job would be too long. So you can now use this bucketization process, let's say, to like balance them in different buckets, to have for example 4 SQL agent jobs and split them into groups, so they are processed either in the same time or in different times, but you have better control what is happening when. So that is an idea, and I think I used this for tables, not for databases, but it worked to improve things. And I didn't mention this as a scenario, but once we dealt with all the stuff, the two big databases were still the processing time was different on different days. And since the database size was kind of the same all the time, well, it was slightly growing as databases do. But the processing time was sometimes like 4 hours or 6 hours. And then there was a question like, what is happening? Why this process is taking half the time more than on some other places, some other times? That's a side comment. I had a perfectly working solution where job was running and was completing, and we only found out that the DBCC CHECKDB was running too quickly. Instead of running the usual 2 hours, it was running 15 minutes. But it never failed. It always completed. And someone noticed that, oh, hey, this process is running too quickly for the usual time, so it's broken. And we found that there was a script for getting the databases. It was somehow broken, and it was sometimes getting the bad tables, like not enough. It was not getting all the tables every time it ran. So it's also a good idea to check for the variations of the times. If it's not running, if it's running too slow, you might get some ideas from this presentation. But sometimes if it's running too fast, there might be something that is breaking the process. But it's a side note, because the topic is if it's why it's running too slow. So going back to that problem when it was running slower than usual, with that busy environment, we noticed that even though the integrity checks were running overnight, let's say 2 a.m. for 5 a.m., they were running kind of slow. And there was a big processing around 1 or 2 a.m., different kind of processing, application processing, or moving data from one place to another. And when we moved the schedule slightly, pushed by 1 hour, it still finished earlier than the original execution, than the previous execution, because there was no clash with other processes. So instead of running for 6 hours, it was running for 4 hours, or sometimes even less than that. So that was also an idea that we didn't necessarily had to improve all the things. Well, it helped because we didn't have a big block of CheckDB running for 12 hours or something like that. But still, moving this slightly to less busier period, which we didn't think that was the case that time. But we moved that a little bit, and it shortened the time. So we moved by 1 hour, and it shortened by 2 hours or something like that. I don't remember the details, but it helped, and that's also an idea for you to check that if you can work with the schedule, and maybe that will help. And the last, I know it's not a great solution, but sometimes you are not able to run CheckDB or any part of that at all because the databases are too large, the system is too busy, and you just don't have any way to run the CheckDB on your system, but you kind of want to still, like on your live system, but you still want to get some assurance that your data are all right, or the whatever you are doing is all right. So there is a part where you can not necessarily offload, but do a different kind of verification where you have your backups, because that's something you have to do. Otherwise, that will be a big issue. If you lose your data, then you lost your data. You don't have your data. And even if there's a corruption, you might be able to track it down. I've been there when I had to restore database and then dig out the healthy data or part of the data. Again, it depends on the application and how important the data are and how busy the environment is. But it was possible to get that from the backup. And the idea to, if you cannot run the CheckDB, is to have kind of like a test restore process on a separate non-production environment, when you can use all the time you have to backup, you have the backup to restore that backup to that machine. I know it doesn't match with the production. You can even if you have time and you have the chance, you can try to run CheckDB on that instance, on that database. But that, just keep in mind, that will be a different environment. That it will be a different file in different storage. It's not the same as the production that you didn't run. But that's something you can do just to have some assurance that your stuff are healthy if you have no other chance to run the CheckDB. And I've experienced that as well, where there was no way to run CheckDB because it was too heavy, too long, and it was causing more harm than it was helping. So yes, that's the maybe not the best advice, but it's an advice, and I've seen that in life. So yeah, that's the summary of the when it's taking too long and it's too heavy, just don't run it. That's if you take away this advice, please don't mention my name. That's all for today. I'm open to questions if you have any. If you want to contact me after this session about this session or anything else, here's my email. I sometimes write stuff on my blog, rarely, but sometimes something appears there. So it's bronowski.it. And yeah, thank you, Kevin, for having me. Do we have any questions?
Yes. So we do have a couple of questions in here. And for anybody else who wants to get your questions in, now is your opportunity. So one of the first questions was, do you need to run DBCC on Azure databases or just trust Microsoft?
Oh, actually, I didn't include that in this presentation, but the advice was it for managed instance? The advice from Microsoft was you don't have to run this on Azure SQL. I need to dig out the message. I was checking that, but I don't remember if that was managed instance. But I think unless you run this on SQL VM, Azure VM, that you would probably check. But Microsoft runs the checks behind the scenes on cloud services.
Yeah, my recollection is they do it for SQL DB and for managed instance, but that if you want to play it safe, you can certainly still run them yourself.
Yeah.
So with Tablock makes an independent snapshot for each table instead of just one snapshot for the entire database.
With Tablock, it doesn't create a snapshot. It just logs the table. It creates the log on the table, and it doesn't create the snapshot. So that's why it was faster, because for that busy environment, it didn't have to do the whole snapshot. I don't think there is a table snapshot feature just for a table.
Yeah, I believe you're right there. I've never heard of one. So, and then there was a comment earlier about one of the points that some of what you're showing is good because big on-prem database is 1 terabyte, but it runs on Sunday, and never really looked into some of the options that you were talking about. So much obliged there. And with that, are there any other questions, chat? Now is your opportunity. Get them in. It is late for Mikey, so let's not keep him up too late.
It's still today, which is fine.
But if you do have a question, just drop in a quick comment. Hey, got a question? And then that way I can vamp. Otherwise, I'll do a soft wrap up. And then if there's a last second question that just slides in, sort of like Indiana Jones going under the dropping wall, then I'll wait for it. But otherwise, everybody, remember next week we are in person at Tech Systems. We'll have a discussion of the data API builder from Microsoft. So we'll have a couple of Microsoft folks on there talking to us and get a chance to see how it works for different Azure data platform technologies. And then in 2 weeks, we'll have our business intelligence and data science meeting. So everything there you can get at meetup.com/trypass. And it looks like we are out of questions. So with that, let's wrap things up for the day. Thank you again, Mikey, for a great presentation. Much appreciated.
Thank you for having me.
Of course. And for everyone else, have not seen that invite for next week. Yeah, just check out meetup.com/trypass. Everything is up there. I think I did see the invitation go out, but there may have been an issue. But still, you can always get them at meetup.com/trypass. And with that, everyone, until we see each other in a future meeting, take care.
Thank you. Have a good evening.